problems 16 through 20 on the 2017 Geometry Regents exam. All right, so starting with number 16. If you've been in class, we have done this problem, but let's go over it again. It says a parallelogram is a rectangle if the diagonals are congruent, the diagonals bisect each other, the diagonals intersect at right angles, or the opposite angles are congruent. So we have 4 different choices. And the question is always a rectangle. So there's one of these properties that if it's true about a parallelogram, it has to be a rectangle. The other 3 may be true, but that doesn't make it a rectangle. So looking at this, I don't want to spend too much time on this. We should know this. I want you to think about this, and this basically gives you the answer. If you look at 2, 3, and 4, they are also true of a rhombus. So when you look at the diagonals bisecting each other, that's true of a rhombus, which is not necessarily a rectangle. The diagonals intersect at right angles. Well, that's true of a rhombus, which is not necessarily a rectangle. The opposite angles are congruent. That's also true of a rhombus, which is not necessarily a rectangle. The only one that guarantees you'll have a rectangle, the only property, is that the diagonals are congruent. And if you think of a rhombus, we've talked about this, when you connect the diagonal of the acute angles, that's going to be different than the diagonal of the obtuse angles. All right? That connects the obtuse angles. Okay, so that's your answer on number 16. Now, number 17. Okay, so let's read this. It says, which rotation about its center will carry a regular decagon onto itself? Okay, a couple things I want you to write down. And also, before I go on, in order to get credit, you need to have written this down right here. Okay, this down. You need to write this down on problem 16. All right, but on 17, a decagon. I want you to write this down. Decagon is a 10-sided figure. You have to know that in order to do this problem. And think decade. Decade is 10 years. All right? So think about that. Now, I also want you to write this down. To figure out how many degrees of rotation it takes to carry a figure onto itself, divide the sides. That should say number of sides. I'm going to change that right now. And what this should say is divide 360 by the number of sides. Okay, so divide 360. Where does that 360 come from? That's the total degrees in a circle. All right. Any rotation that is a multiple of that number will carry the figure onto itself. All right. So any number, any value that is a multiple of that number will carry the figure onto itself. All right. So think about that for a second, and I'll be right back. All right, so looking at this, we need to do 360 divided by 10. That gives us 36. Okay, on a lot of these problems on the exam, they'll have the answer 36 there. Okay, but they don't have that here. So you actually have to think about what is a multiple of 36. Which one of these numbers? Well, remember, multiples would be 36, 72, because 36 times 2, 36 times 3 would be 108. Now, what you could do with the values you see here is take each one of these values and divide by 36, and to see which one gives you a whole number. Well, 54 obviously doesn't. Let's try the other one. So I'm going to get my calculator here, and I'm going to see which one does that. So I get, all right, so I'm going to do my first one, which is 162 divided by 36. Nope, that's not right. So then I'm going to do 198 divided by 36. Nope, that's not right. Then I'm going to do 252 divided by 36. There we go, 70. Okay, so our answer is 252 degrees. So, and I want you to think about something. When it says rotating a figure, how many degrees to rotate onto itself, think about this. I have what I have right here is two decagons. And if I take this one and I rotate it, it's not onto itself, ah, there it is. That's 36. Not onto itself, this would be 72. This would be 108. This would be 144. This would be whatever that is. I'm getting slow. Is that 180? Okay, whatever the case, if I rotate it 252, I believe that would be about right here, it would be onto itself. Any of these other degrees is not going to rotate it onto itself. Okay? So that's what we're looking for here. All right, let's look at the next one. It says the equation of a circle is x squared plus y squared minus 6y plus 1 equals 0. What are the coordinates of the center and the length of the radius of this circle? All right, so I want you to write down the equation of a circle in standard form. Depending on when you watch this, we have not done this in class, but I do want you to write this down. Now, looking at this, whenever you look at standard form, whenever you have this value, that r stands for the radius. I do want to say that. So r is equal to the radius. All right? So whatever value you have there when an equation is in standard form, equation of a circle, you would take the square root of that value and it would give you what the radius of the circle is. Okay? But this equation that we have here is not in standard form. We have to put it in standard form. We're going to use a process called completing the square. All right, so I want you to write this down. We're going to look at that in class, again, depending on when you watch this. All right, so what we need to do is look here. We have an x squared, and we don't have any more x terms. So the x is okay. The x squared is okay. But when you look at the y squared, and then you see a minus 6y, that's telling us we need to do something there because it has that extra y term. So the first thing we're going to do is subtract this 1 on both sides. So we're going to have x squared plus y squared minus 6y. I'm going to have you leave a space right here. I'm going to have you leave a space right here. And we're going to fill in a number there to do this process of completing the square. And then we're going to have equals -1. And we're also going to add something over here. Okay? Now, the process of completing the square is that you take, so we're just going to look at the y term. We're going to look at this y term. We're going to take half of that. So we're going to do -6 divided by 2, which is equal to 3. Then we're going to square that number, which is 9. So what we're going to do is add 9 here. So we already have the plus 9. It's always going to be a positive number because you're going to square your value. So if your value is -3, which this one was -3, you square, you get 9. If the value is 3, you'd square, you'd still get 9. All right, we don't want to change this entire equation. So since we added 9 to this side, we need to add 9 to this side. All right? Now, what that does, when you look at this part right here, it's always going to come out with something squared. So we're going to end up with y minus 3 squared. All right? Go back to algebra. If you multiply y minus 3 squared out, you end up with this. All right? So we're going to rewrite this equation now. We end up with x squared plus y minus 3 squared is equal to 8. Okay? Now, if we take, so we can look there, I'm going to rewrite this up here. Rewrite up here so we can look at it. We have x squared plus y minus 3 squared is equal to 8. Now, like I said, this is standard form. So we have something that we need now. We have it in the form we need. Now, take 1 second here. Okay, let's look. I actually wrote something else here. This is actually, I took the blue and I actually put that in standard form. Technically, that was not in standard form, so I wrote it actually in standard form down here. A couple things. To find the center, you just look at the values you have, your x and y values, the numbers that are next to your x and y. When you look here, now that's going to be 0 because x minus 0, x plus 0, that doesn't matter. So we know our center is 0. Then when you look at this value, do you see how it's a -3? Okay, when you're finding the center, it's always going to be opposite. So if it's a negative, that means our center point is going to actually be +3 for the y. So that means that our answer is already up there. We can tell that it is number 1. Now also, if you take the square root of 8, that'll give you the radius. And if you notice on 3 and 4, you have this radius. And then on both 1 and 2, you actually have 2 radical 2. Well, how did that come about? Well, that's because you simplify radical 8, and you end up with 4 times 2, and then that's 2 radical 2. So you really have to determine it by the center. By the center. Okay, we're going to work more on this, but there's a little preview. All right, looking at number 19. It says parallelogram. Okay, you already know it's a parallelogram. All right, ABCD has coordinates of 0, 7, 2, 1. Which statement would prove that ABCD is a rhombus? Okay, I want you to write down the key figures of a rhombus, key features of a rhombus. All sides are equal in length, and the diagonals are perpendicular to each other. Diagonals are perpendicular to each other. So we have 4 different options of things that would prove that this is a rhombus. And notice, they give you the coordinates of A and C. So those are actually diagonal to each other. So what I would do is, you know you have graph paper on the back of the test available to you. I would go and graph these points and go from there. So I already have them graphed here, both 0, 7, and 2, 1. So I want you to go ahead and graph those, and we're going to look at some of the answers. So the first answer choice, if we go back here, is that the midpoint of AC is 1, 4. All right. Now remember, AC is a diagonal, okay? Whenever you name something, right, you always go in order. So A, B, C, D. So AC is a diagonal. We don't know where the other points are, but we know AC is a diagonal. Even if you had it like this, A, B, C, D,
again,
no matter how you letter it.
Your 9th period class, we will be conducting another hall.
All right, so look at the first one. It says the midpoint is 1, 4. So let's look at that. Now, that's the midpoint of the diagonal. So let's just say that's here. All right. Does that prove that this is a rhombus? I don't think that proves it's a rhombus. I don't know, you could have, this could be a rectangle, right? That doesn't prove anything. So let's go ahead and look at the next one. And I'll be right back in just a second. All right, so let's go back and let's look at number, okay, so we know 1 is not it. That doesn't prove anything. Okay, the length of BD is radical 40. So what they're saying here is, let's look at this. I'm going to look at this example over here. They're saying that this here, this diagonal is radical 40. All right. So, well, let's see. What is the length of AC? So if I do the length of AC, I'm going to get rid of this little midpoint here. If I do the length of AC, all right, so AC would be this. So that would be 2, this would be 1, 2, 3, 4, 5, 6. So that'd be 2 squared plus 6 squared is equal to C squared. So C is equal to the square root of 40. Now, that means that both of these diagonals are radical 40. Okay, but that doesn't prove that it is a rhombus. Matter of fact, a rhombus, typically, you're not going to have the diagonals. It could, but the fact that they are congruent, the diagonals, doesn't prove it's a rhombus. All right, so let's go back. Let's get rid of that one. All right, what about the slope of BD is 1 over 3? All right, so I'm going to go ahead here. I'm going to erase some of these things here and get rid of some of these things here. All right, so what they're saying is the slope of BD. Now, we don't have BD. We don't know where BD is. But we do know we can find the slope of AC. This is one of the diagonals, right? And the slope of that, remember, rise over run. So the slope is equal to negative 6 over 2. So the slope is going to be negative 3 over 1 of AC. So if BD, so the slope of AC is equal to negative 3 over 1. And if they're saying that the slope, will this prove that it's a rhombus? Well, if you have negative 3 over 1 and 1 over 3, they are perpendicular, which means the diagonals are perpendicular, which proves that it is a rhombus. There we go. All right, let's go to the last one. Okay, let's read this problem. It says point Q is on MN such that MQ to QN is a 2 to 3 ratio. If M has coordinates 3, 5, and N has coordinates 8, negative 5, the coordinates of Q are.
Teachers, please close and lock your doors. All available administrators and SSO.
All right, let's look at the formula. We've done this a number of times. Let's look at the formula here. Remember this. Okay, your X1. All right, now I'm going to have you actually go, and I want you to graph this. Graph it. Very important that you graph it. So I'm going to actually go ahead and do that on the next page. Very important that you graph. You always want to do that. So I'm going to go ahead and do it here. It's just very helpful. On any problem that you can graph, I would suggest doing it. All right? So I'm going to use just a corner here. You only have a certain amount of graph paper, so you don't want to use a lot of it if you don't have to. All we need are the points 3, 5. And the point, so that's M. And then the points N, 8, negative 5. And this is N. So now I'm going to make my line here. And right here. Okay, so what it's saying, the question is saying, there is a point Q on here such that MQ to QN is a 2 to 3 ratio. So if I take, say for instance, I say I have Q, right? Right here. Now, MQ to QN. Now, think to yourself, should MQ be bigger or QN? So let's look back here. Since we have MQ would be with the 2, QN would be with the 3, that means that QN needs to be bigger. So we need to keep that in mind. So if we get to the end of our problem and we have our point like here, well, that's a problem because QN is smaller, okay? So just keep that in mind. Now remember, you need to find the slope. So we're going to find the slope. Remember that was our first step? I had you guys write down the steps. One of them was to find the slope. So our rise in this case is negative, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's negative 10. The run is 1, 2, 3, 4, 5, so that's 5. Right, so our slope is 10, negative 10 over 5. Let's go back here. So the slope, or let's see, slope, which is rise over run, is equal to negative 10 over 5. So now we can fill into our formula here. All right, so we have x1. Well, what's our x1? What's our starting point? That's right here. All right, so we're going to have 3 plus, what's our fractional part? Remember, you take the ratio, use and add that together, so 2 plus 3 is equal to 5. And then this number, the first number, will be on top. So it's 2/5 of, right, the run. So the run is 5. Okay, that's going to give you your x value. So 2/5 of 5, so that's 3 plus 2/5 of 5 is 2. So that's equal to 5, right? So our x value is 5. And that eliminates now 3 and 4, right? Now we find the y value. Our y value is going to be the same thing. Our y1, which is 5, plus the fractional part, which is still going to be 2/5. Make sure you make the rise negative. All right? Make the rise negative. It goes down. Our line's going down from the left to the right. So it's going to be negative 10. All right, so we're going to have 5 plus 2/5 of 10 is going to be 4. I'm sorry, negative 4. Right? And then you have 5 plus 4, which is 1. So our y value is 1. And let's just check to see if that makes sense. Let's go back to our graph. And if we do 5, 1, 1, 2, 3, 4, 5, and 1, that makes sense. We have NQ here, right? And then we have QN here. MN is definitely smaller than QN, which is what we wanted. So that looks like that is our answer. There we go. So we're done with problems 16 through 20.